This presentation covers information about pesticide formulations. By the end of this presentation, you should be familiar with some of the more common abbreviations associated with formulations, and you should know the major advantages and disadvantages associated with different types of formulations, especially those aspects that affect human health, plant damage, and equipment wear. You also need to understand the role adjuvants play in achieving quality pest control. Prior to talking about formulations, let's review some basic terminology. The active ingredient in a pesticide formulation is the actual chemical in the product that controls the pest. EPA requires that the active ingredients are clearly stated on the label. Some products may contain several active ingredients, and each one must be listed separately in the active ingredient statement. The inert ingredients are materials added during the formulation process for several different reasons. But inert ingredients don't have pesticidal activity. Inerts may simply be added as bulk material to aid in handling the product. They may be added to increase the safety of the product, or they may help the product be more effective. Phytotoxicity is a concern with some formulations. Simply defined, phyto meaning plant, toxicity means injury. So phytotoxicity is plant damage. Shortly, we'll discuss which formulations, due to their ingredients, pose concerns for phytotoxicity. Adjuvant is a technical term that means additive. Adjuvants are products that are added to a spray tank mixture and assist with pesticide stability, mixing, or control effectiveness. So, if we look at the components of a formulated product, or a formulation, you'll always have the active ingredients and each and every active ingredient listed on the label. Additionally, there are many different materials added as inert ingredients. The inert ingredients may include materials such as water for bulking the material so a user can easily measure the appropriate dose needed. Some formulations include emulsifiers to assist the tank mixing and stability of the product in the tank mix. Some active ingredients don't mix well in water, and during the formulation process are mixed with petroleum solvents. In some other formulations, the active ingredient is bound or attached onto dry carrier materials like clay talc. As you can see from this list, some materials are added to the formulated product to assist the applicator, such as dyes that show where the material has been applied. Other inerts are surfactant materials that increase the effectiveness of the active ingredient. So the formulation includes the active and inert ingredients, but only the active ingredients are listed on the label. The inerts are largely the trade secrets of the manufacturer and help their product be more competitive by increasing safety or effectiveness or make the product easier to handle. When you mix up a spray batch, you're adding the formulated pesticide product with some type of diluent, typically water or oil. Some labels recommend the addition of certain adjuvants or spray additives. Remember, we call those tank mix additives adjuvants. You must be very familiar with this term. Here's an ingredient statement for a herbicide. The product name is Lexone DF. Often the product name tells you something about the formulation. DF usually means dry flowable. Metribuzin is the active ingredient, and this product only contains a single active ingredient. 25% of the product is active ingredient and 75% is inert. This is a dry formulation, so we can assume that most of that 75% of inerts would be a dry, clay talc type carrier. Most dry formulations that are mixed with water also have emulsifiers added to assist with mixing the active ingredient on the clay carrier with water. So this formulation most likely has active ingredient, clay, and emulsifiers. It could also have some surfactants or dyes or other additives to make it easier to handle or more effective. Again, those inert ingredients are the trade secrets. Let's compare these two products. Both have metribuzin as the active ingredient, and both contain 25% active ingredient, so their potency is the same. They differ in that one is a dry flowable formulation, and the other is an emulsifiable concentrate, liquid formulation. If we wanted to know how many pounds of active ingredient there was in a container of dry product, we multiply the percent active ingredient by the weight of material in the container. So if we had 10 pounds of product and the dry formulation was 25% active ingredient, we would multiply 10 pounds by 25% and determine there is 2.5 pounds of metribuzin in the container. In the lower example with a liquid formulation, you cannot simply multiply by the percentage because that would give you the percent of volume, and you usually need to determine the weight of the active ingredient. So you have to convert the volume of product to a weight equivalent, and all liquid formulations provide that conversion in the active ingredient statement. You can see with Lexone 2E that each gallon container contains 2 pounds of metribuzin. So a 2.5 gallon container contains 5 pounds of metribuzin. On the state pesticide exam, you'll most likely have to calculate the weight of active ingredient found in a container. Let's review why chemical manufacturers add inert ingredients. Manufacturers add inert materials that allow their active ingredients to be more easily measured, mixed, and applied. Sometimes manufacturers alter a formulation to increase safety, for example, making a dry flowable instead of an emulsifiable concentrate. And remember, companies are competing in the marketplace. If they add inert materials that give their product a competitive boost in penetration, selectivity, or increased effectiveness, they will, and they will market those advantages. Adjuvants are pesticide additives. Some adjuvant materials are added directly into formulated products to provide competitive advantages. Additionally, some pesticide labels recommend the use of certain adjuvants, and these are sold separately as adjuvant products. They're mixed directly with the product when making up a spray batch. Common adjuvants that are recommended by some labels for tank mixing are surfactants, spreaders, or wetting agents that assist with effectiveness. Colorants or dyes may be used to help ensure application coverage, or they may be used for safety reasons. Buffers are mixed with the spray mix water prior to adding products that are highly sensitive to pH, the acidity or alkalinity of the water used in the spray mix. Anti-foaming agents and safeners may be used to improve the compatibility of the spray mixture. A pesticide brand name may contain a lot of useful information about the pesticide formulation and amount of active ingredient. The letters that are typically found in the brand name are abbreviations for the type of pesticide formulation. Soluble powder is SP, DF is dry flowable, and EC is emulsifiable concentrate. The number used in a brand name often correlates with the rate of active ingredient in the formulation. 40DF is a dry flowable formulation with 40% active ingredient. ADSP would be a soluble powder with 80% active ingredient. With liquid formulations, numbers usually relate to the number of pounds of active ingredient found in a gallon of the formulated product. So a Claim 1EC herbicide contains 1 pound of active ingredient for each gallon of formulated product. This slide shows a listing of the more common abbreviations that describe the formulation. D is for dust and G is for granule. These are applied in a dry form. SP for soluble powder, S for solution, WP for wettable powder, EC for emulsifiable concentrate, DF for dry flowable, WDG is for water dispersible granules, and WSP is a water-soluble packet. All of these are mixed with water. ULV is ultra-low volume, and it may or may not be mixed with water. RTU is ready to use as is. There are many different abbreviations, even GL for gels and LO for low odor. There are choices for you to make when selecting a product, and the formulation type can play a key role in your selection process. Evaluate formulation advantages and disadvantages. We'll discuss them shortly for the more common ones. You'll need to have the appropriate equipment to apply these different formulations. ULV formulations cannot be applied with a typical boom sprayer. Timing and placement may factor into what formulation is best to make certain that you can apply the product when and where it's needed. For example, a highly volatile ester formulation should not be used under high temperatures and low relative humidity conditions. It's important to consider whether the formulation will get the product to the target pest and remain active long enough to manage the pest. When you mix a product into the spray tank with water or another diluent, what's really happening? Some products actually dissolve and form a solution like sugar dissolving in water. Other mixtures are suspended clay particles mixed and scattered through the mixed water. We call these suspensions. Suspended particles, not dissolved. Suspensions are like cocoa in water. Another common mixture is an emulsion, when you have oil-based material suspended in the mixed water. Let's study each of these more closely. You get a solution in your spray tank when the product you add to the water actually dissolves. The product is water soluble. These products are usually transparent, and you can see through them. Once soluble liquid products or soluble dry powder products are mixed with water, they form the solution and won't separate out of the spray mix. You only need to agitate the tank to get them into solution. Then agitation is no longer necessary. The spray mix is transparent. A suspension is a mixture of fine particles dispersed in a liquid. When you make hot chocolate and mix the cocoa powder, you are actually drinking a suspension of cocoa powder particles suspended in milk or water. The cocoa doesn't dissolve, and if left to rest on the counter would separate out over time, and you'd have to stir it up to get it evenly mixed again. Suspension mixtures require continuous agitation, or the particles won't remain evenly dispersed and suspended in the liquid. Wettable powders, dry flowables, and water dispersible granules are good examples. The active ingredient of these dry formulations is bound to the outside of a dry carrier, which is then mixed with an emulsifier to cause the dry powder to become slick. Once mixed with water, the emulsifier keeps the suspended dry particles from sticking together. Agitation is required to keep the dry particles that carry the active ingredient suspended in the spray mix. An emulsion is when one liquid is dispersed within another liquid, like oil and water. With pesticides, the active ingredient is usually pre-dissolved in an oil-based solvent, like a petroleum solvent. Emulsifiable concentrate formulations form an emulsion. When the oil plus active ingredient combination in the formulation is mixed with water in the spray tank, the oil droplets containing the active ingredient are suspended in the water column, forming a white, milky spray mix, called an emulsion. It's basically oil drops suspended in water. An emulsion usually requires some agitation to keep the mixture from separating. Let's look more closely at some formulations. An emulsifiable concentrate, or EC, has an active ingredient that does not dissolve in water. So the active ingredient is mixed with at least one petroleum-based oil solvent. To aid in mixing with water, they add an emulsifier agent. The emulsifier is slick like soap and is critical to aid the oil plus active ingredient combination with water. Our eyes perceive emulsions as white because light refracts off the oil droplets in water. Can you think of an emulsion in your refrigerator? White and watery with oil or fat droplets in it? What's the difference between regular milk and low-fat milk? One is thick and the other is watery. Here's an important point for you to remember. When you pick up an EC, what you really have is the active ingredient, a petroleum solvent, and an emulsifier. The inerts in an emulsifiable concentrate formulation pose different risks and advantages when compared to other formulations. Make certain that you consider these. There are several advantages to emulsifiable concentrates. They are relatively easy to handle and measure. They require only a little agitation to get them initially mixed or remixed if they settle. They're not abrasive to most application equipment and don't plug screens or nozzles. ECs leave little visible residue on treated surfaces. However, both the petroleum-based solvents and those soapy emulsifiers that are in the formulation pose risks to some sensitive plant tissues. Read the label for phytotoxicity or plant damage precautions. Due to the oil-based petroleum solvents, ECs are readily absorbed into human skin. Oil-based solvents easily penetrate skin just like lotion. They also pose concerns for eye injury. Another concern is that the solvents can cause deterioration of rubber or plastic hoses, discoloration of painted surfaces, as well as being corrosive and flammable. This would not be a good product to select to spray shade trees that have cars parked nearby. So prior to selecting or handling an EC, consider the hazard of the product. Read the label for precautions for you and sensitive plants. Understand the impacts the solvent portion of the formulation has on equipment parts and painted surfaces. Some pesticide active ingredients dissolve, like whiskey, in water. When mixed, they form a solution that won't settle or separate. Solutions may be used in any type of sprayer, indoors or outdoors. Liquid solution formulations are easy to measure and mix. They don't need agitation. They're not abrasive to application equipment and don't plug screens or nozzles. Phytotoxicity is not a concern. Solutions are used both indoors and outdoors. There are no disadvantages to solutions. Just as the name implies, these formulations are ready to use and do not require any further dilution. They are extremely easy to handle, but are usually very low concentration materials, resulting in quite high costs. They are a good choice to ensure that there's no leftover spray mix that becomes a disposal problem later. Ultra-low volume formulations can be diluted with very small amounts of a specific carrier or used without any dilution. Pesticides formulated as ULVs are most commonly used in outdoor applications in specific situations, and they require specialized application equipment. Because of the application of very low volumes delivered by very small droplets, ULV applications have a very high potential to drift off target. ULVs are used in mosquito control and in some forest and agriculture situations. ULVs have similar advantages to emulsifiable concentrates and soluble liquids in that they are easy to handle, require no or little agitation, they are easy on the equipment, and don't leave residues. They're used indoors or outdoors. The drift hazard due to the small mist-like droplets is significant, and they require specialized equipment. ULVs have solvents in the formulation that can cause wear on rubber, nylon, and plastic. When using ULVs, calibration is critical since you're applying a highly concentrated form. Invert emulsion formulations are similar to ECs, and they utilize a petroleum solvent and water, but they're mostly oil-based. The carrier for the tank mix is oil, not water. So you have a heavy oil-based mixture with very little water. Again, can you name an invert emulsion in your refrigerator? Mayonnaise, lots of oil. Because of the thickness or viscosity of the oil-based mixture, spray droplets are large and heavy, so they don't drift. Invert emulsions also evaporate more slowly than water-based mixtures, resulting in reduced drift and runoff. The oil carrier acts as a sticker spreader, helping to improve the coverage and absorption of the product. Invert emulsions are mostly commonly used in areas where drift to susceptible non-target plants and sensitive areas is of concern, like along rights-of-ways. Most aerosol formulations have a very small amount of active ingredient. The aerosol formulations that most people are familiar with are self-contained units, bug sprays. These units contain an inert gas under pressure, and when the trigger is released, the formulation is dispersed in very fine droplets. Because of small droplet size, aerosol formulations have a high drift potential and an increased risk of inhalation exposure. Aerosol treatments to large areas require very specialized equipment. Due to the small mist produced, drift and the applicator's personal protection are concerns. A bait formulation is an active ingredient mixed with food or another attractive substance. The bait either attracts the pest or is placed where the pest can find it. The amount of active ingredient in most bait formulations is quite low, usually less than 5%. Baits are used inside structures to control ants, roaches, flies, and other insects, and they're used for rodent control. Baits are typically purchased ready to use. Coverage isn't critical, but where you place them is. Baits can be effective in controlling pests that move in and out of the area where the baits are placed. Some of the new liquid baits are highly successful in areas where water is limited or where other bait materials have failed. Be very careful with placement of baits because they are magnets for children. Also consider access to the baits by domestic animals. When using baits, realize you don't have control of where the pest may die, and dead pest odors can create their own problems. Replenish baits and remove old stations so you don't inadvertently provide food once the bait becomes inactive. Pastes and gels are formulated baits. They're odorless and easy to place. Pastes and gels provide for minimal exposure when used correctly. However, high temperatures can cause them to melt and they can stain porous surfaces. If possible, clean up previous material to minimize unsightly buildup. Let's shift and look at dry formulations. Most dust and granular formulations are ready to use. Dust can be very effective in hard-to-reach places such as cracks and crevices for cockroach or ant control. Just as the name indicates, the inert ingredients in a dust formulation are very fine dry particles such as talc, chalk, clay, or volcanic ash that has the active ingredient stuck to the outside of the particle. Granules use larger particle sizes. Dusts and granules have a low percentage of the active ingredient. As you spread the dust or granules around, you are spreading the active ingredient. Calibration and application can be a challenge. Because of the fine particle size, dust can easily drift off target and can easily get on your skin and in your eyes, throat, and nose. Granules are similar to dust, except the particles are larger and heavier. The terms granules and pellets are often used interchangeably, but unlike granules, pellets are a uniform size and shape. In these dry formulations, the relatively low amount of active ingredient either coats the inert material or is stuck to the outside of it. Once applied, the active ingredient is slowly released. Granule pesticides are usually used in insect, weed, and nematode control and often used in soil and aquatic environments. When applied to soil, they usually must be incorporated into the soil by water or cultivation. Because of the particle weight, granules used in aerial applications pose little hazard from off-target drift. Be careful with granules and pellets because they can be mistaken for food. There are several formulations that are sold dry, but are intended to be mixed with water. These include wettable powders, water dispersible granules, and dry flowables. These are all fairly similar formulations, with the exception that wettable powders are very light and airy and more difficult to measure. The active ingredient is attached to the outside of a dry carrier. An emulsifier is added to help with mixing them into water. When the dry material that holds the active ingredient is mixed with water, the dry material is suspended in the spray water. Wettable powders are dry, finely ground formulations that are similar to dusts, but are mixed with water. Can you imagine how well dirt and water mix? For this reason, a slicking agent or emulsifier is also added to the formulation to aid in tank mixing. Wettable powders typically contain at least 50% active ingredient, so are quite concentrated. The particles don't dissolve in water, but are suspended, so they settle out quickly unless you maintain constant agitation. Wettable powders are easy to store and fairly easy to measure and mix. However, they are easily inhaled if mishandled. They pose less hazard to humans and plants since they do not contain a petroleum solvent. They require constant agitation to keep the dry particles suspended in the spray mix, and wettable powders can be difficult to mix in alkaline or hard water. Wettable powders can be quite abrasive to pumps and cause significant wear in nozzles constructed of soft metals. They leave visible residues when they dry, which can be a problem on ornamental plants in high traffic areas. Dry flowable and water dispersible granules are just like wettable powder formulations, except the active ingredient is prepared as granule-sized, bead-like particles, not as a powder. These bead-like particles are more easily handled, especially when measuring and mixing since there is no dust. Both water dispersible granules and dry flowables have similar advantages and disadvantages as the wettable powders. Treated surfaces have visible residues. They're abrasive to pumps and nozzles, and spray tank agitation is required. The big advantage compared to wettable powders is that water dispersible granules and dry flowables are easier to measure and don't pose the inhalation concern when measuring and mixing. Soluble powders look like wettable powders, but they easily dissolve in water and form a true solution, just like powdered sugar dissolves in water. Because they truly dissolve, soluble powders are easy to store and use. There are few powder active ingredients that truly dissolve in water. Soluble powders are easy to measure and mix. Since they don't contain the solvents in their inert ingredients, they don't pose additional concerns for humans or plants. Since they dissolve, no agitation is necessary and there is no equipment wear. However, soluble powders do pose a high risk of inhalation exposure during measuring and mixing because they are fine dust-like particles. Flowables contain insoluble solids that are finely ground and premixed with a liquid during the formulation process. So you're actually buying a wettable powder that's already in a slurry. Flowable formulations are then mixed with water for application and are pretty easy to handle and use. Since they form suspended dry particles in the spray tank, they require good agitation and may leave visible residues. There are other types of pesticide formulations too. A microencapsulated formulation is when a liquid or dry pesticide particle is coated in plastic. This formulation is mixed with water and applied as a spray. The plastic coating breaks down and releases the active ingredient. The encapsulation of the active ingredient reduces the risk to applicators. However, this formulation is very hazardous to bees. Because microcapsules are about the same size as pollen grains, foraging bees can carry the capsules back to their hive and poison the entire hive. Water-soluble packets are packets containing a precise amount of several different formulations in a special bag that is dropped into the spray tank with the water. The pesticide is slowly released into the tank as the bag dissolves. Water-soluble packets reduce human exposure during mixing. Again, any product that controls a pest is a pesticide, so attractants and repellents are pesticides and can be formulated in many different fashions, from aerosols to odors formulated in traps. Some pesticides are impregnated onto surfaces such as plastic or granules. Flea collars and cattle ear tags are good examples of pesticides impregnated onto a surface. Pesticides, usually herbicides, are premixed with fertilizer to achieve feeding and weeding with the same application. Animal systemics are also formulated pesticide products. Fumigants are liquids or solids that are active as a gas. Fumigants are non-selective and highly toxic to a wide range of living organisms. They're typically used for structural pest control in food and grain storage facilities and in the soil or greenhouses. Because fumigants are very toxic and replace the air with toxic gases, they require special precautions and protective equipment when handling and applying. To save time, labor, and fuel, many applicators combine pesticides in a tank and make only a single application. Tank mixing is convenient as long as the combinations are compatible. Incompatible tank mixes are a nightmare. Some manufacturers realize their products will be tank mixed and actually recommend mixes on the label that they know are compatible. However, if you are mixing two products together and don't know about their incompatibility, you need to conduct a jar test. When two or more chemicals that are mixed are incompatible, they can form precipitates or clumps in the tank. Heat can also be generated from chemical reactions. With incompatibility, a chemical reaction may occur breaking down one or more of the mixed pesticides, rendering it useless. Some chemicals become extra toxic and can cause damage to plants. Again, if the label does not specifically mention a tank mix, it's wise to conduct a jar test with a small amount mixed together to make sure everything is fine with the mixture and that the mixture does its job. We defined adjuvant at the beginning of the module. Adjuvants are additives used in a tank mix to assist with activity on the plant or insect, or added to assist in the performance of the mixture. Surfactants are a group of adjuvants that affect the surface tension and surface activity of the spray. Common surfactants include the wetting agents and spreaders which alter the surface tension of the spray droplet. Altering the droplet's surface tension allows the droplet to contact more plant tissue, thus resulting in greater exposure. This type of adjuvant is important when applying a pesticide to a plant with hairy or waxy leaves. Make sure you read the pesticide label before you use an adjuvant because many pesticides have very specific recommendations regarding surfactants. There are a variety of other adjuvants as well. Buffers are critical for some products that would immediately break down when mixed in hard water. The buffer is added to the spray water to change its pH prior to adding the pesticide. Compatibility and defoaming agents assist with mixing, and safeners reduce injury to some plants. Colorants or dyes are used for either safety reasons or to assist the applicator in seeing what area has been treated and what area has not been treated. Thickeners are used to reduce spray drift. With so many different types of adjuvants available, it can be an overwhelming task deciding which adjuvant to use. Always read the pesticide label and follow the label directions. Some products specifically recommend their use, and others clearly warn the applicator not to mix them with their product. When using any adjuvant, make sure it's one specifically designed to be mixed with pesticides. Non-tested adjuvants can interfere with a pesticide's performance. If the label does not specifically recommend the use of an adjuvant, you may want to conduct a small-scale jar test or efficacy test before you spend a lot of money. With some products, the manufacturer already added some of these adjuvants because they are needed as spray tank additives. In summary, all pesticide formulations contain active and inert ingredients. Many dry and liquid formulations are available. Adjuvants can be added to pesticide formulations, but you should always read the pesticide label to determine if an adjuvant is necessary. It's important to understand the advantages and disadvantages of the different formulations prior to making your selection, and then choose the formulation that will work best in your situation. There are several factors you need to consider when selecting a formulation. Ask yourself, how safe is it for you to handle? How easy is it to measure and mix? What are the concerns for human exposure? Does the formulation pose concerns for plant injury, or will residues be visible? And do you have the appropriate application equipment to apply the formulation? Question 1. Which of the following formulations typically has the lowest rate of active ingredient? A. Dusts, D. B. Wettable powders, WP. C. emulsifiable concentrate, EC, D. Soluble powder, SP. Answer: A. Dusts typically contain less than 15% active ingredient. The other three can be highly concentrated, like 80% wettable powder or an 8-pound per gallon emulsifiable concentrate. Question 2. Which type of nozzle would pose a concern when using soluble powder formulations? 1. No nozzle type poses a concern. 2. Brass nozzles. 3. Aluminum nozzles. 4. Nylon nozzles. A. 1 only. B. 2 and 3 only. C. 2 and 4 only. D. 3 and 4 only. Answer: A. Since soluble powders truly dissolve, they contain no abrasive ingredients like wettable powders or corrosive materials like emulsifiable concentrates, so the nozzle type does not matter. Question 3. Which of the following are considered surfactant-type adjuvants? 1. Spreaders. 2. Buffers. 3. Wetting agents. 4. Colorant dyes. A. 1 and 2 only. B. 1 and 3 only. C. 2 and 3 only. D. 3 and 4 only. Answer: B. Spreader and wetting agents affect how sprays wet the surface of a plant and are both considered surfactants. Buffers and colorant dyes are additives or adjuvants, but don't have any surface action. This presentation was authored by Carol Ramsey, Becky Hines, Carrie Foss, and Brett Johnson of Washington State University Urban IPM and Pesticide Safety Education. In addition to sources noted on the image, graphics were provided by the following sources: Nevada Department of Agriculture, University of Missouri-Lincoln, Virginia Tech, Washington Department of Agriculture, and Washington State University. This presentation material was reviewed by Beth Long, University of Tennessee, Ed Crow, Maryland Department of Agriculture, Jean Kasai, U.S. EPA, and Susan Whitney King, University of Delaware. Narration was provided by Drex Rhodes, Washington State University Information Department.